ARM is a leading provider of microprocessor IP for the embedded industry with over 20 billion processors shipped into the marketplace. ARM technology is at the heart of billions of devices connecting our world. From the full internet, everywhere across any screen from your phone to your desk to your home to intelligent connectivity that enables business, education, and health advances. ARM low-power technology provides complete scalability and optimal integration from ultra-low-cost microcontrollers to high-performance consumer devices and beyond. ARM is the architecture behind the new wave of innovative mobile and consumer devices empowering our connected world. The future revolves around connectivity. If you look at Morgan Stanley's view on the factors behind the computing evolution, you begin to realize the potential growth in this new era of the mobile internet, but it really only tells part of the story. The computing arena is not where all this growth has originated from. It's much bigger than that. The future is universal connectivity, but not just the computing area. It is everything and throughout our daily lives, from our workplace to our personal lives, in our homes, in our cars, and even when we are relaxing on the beach. Connectivity will be a 24/7 lifestyle. The Internet of Things driven by universal connectivity is the next big wave, and ARM is at the heart of it. Also, before these devices ever hit the market, ARM IP plays an integral role in the development of system-on-chip designs that are the backbone of these products. From processors to pads, ARM provides a broad IP offering tuned for specific foundry processes and process nodes from 250 nanometers to 20 nanometers. ARM's Artisan Physical IP ensures optimal CPU implementations across the entire range of the ARM Cortex processor family, enabling high-performance, low-power designs for high-end consumer and mobile devices, to optimal low-power platforms for real-time embedded devices and energy-efficient microcontrollers. ARM has established strategic R&D and design collaboration with all the leading foundries, including Common Platform Group, Global Foundries, HH&EC, IBM, Samsung, SMIC, TSMC, and UMC. These agreements enable our mutual customers to achieve optimized system-on-chip SoC designs based on ARM processors and a wide range of process nodes extending down to 20 nanometers. Several of these products are available on our Design Start portal. That's designstart.arm.com, where you can try front-end views of these products for free. Also, many of these platforms are foundry-sponsored, so they are completely free for you to access front-end views and try before you buy.
Hello, my name is Xiangyi Qiang. I'm the Senior Vice President of R&D at TSMC, and I've been asked to share my perspective on the recent agreement between ARM and the TSMC to achieve optimized system-on-chip on TSMC process nodes extending down to 20 nanometer. It marks a technical and business collaboration that will help designers optimize the power, performance, and area challenge for ARM co-manufacturing in TSMC process technology. Designers will be able to bring their SoCs to market through shorter design cycles that quickly thrust their innovations into the global marketplace. Let me end on a personal note by adding my personal thanks to all of the ARM engineers and executives who work so hard and so diligently to bring this collaboration together for the good of the entire semiconductor industry.
Hi, my name is Sean O'Kane, Executive Director with ChipEstimate.com and ChipEstimate TV. My guest today is Anna Hunter, Vice President of Foundry Services at Samsung. Thank you very much for joining us today.
Hi, Sean. Thanks for having me.
You know, ARM is leading the wave of mobile device innovation along with IP development built on early foundry partnership with Samsung. Anna, Samsung has a long history of collaboration with ARM, so could you tell us how have customers benefited from this long partnership between Samsung and ARM?
Well, Sean, I think the partnership's been great for customers because we have been working together for so long that we've really optimized our process together with ARM's IP, starting all the way back at 65 nanometer through 45 nanometer, 32, 28 nanometer, and even 20 nanometer today. So we've really learned how to hone our capabilities and give customers the optimum performance, power, area, budget through this collaboration.
So what has been the nature of the ongoing collaboration at 32 nanometer and 28 nanometer?
Each technology node we start collaborating a little bit earlier, and 32 nanometer introduced high-K metal gate, so that was a new opportunity for really improving the performance and reducing the leakage of the process technology and the physical IP, and we really took advantage of that by very close collaboration and optimization of both the physical IP as well as the process technology.
Great. Has the process technology been proven with any early demonstration vehicles with ARM?
Yes, as a matter of fact, in 32 nanometer we did a test chip together with ARM, which we called Tesla, which was their Cortex A9 core on our process, and it achieved over 1.6 gigahertz, performance. So that was very exciting for us and for customers to see that proof point.
Yeah, and recently Samsung announced the qualification of 28 nanometer, a low power device. And what has been the result of this test vehicle?
28 low power is a very exciting node for us. It's our second generation of high-K metal gate. It's built on all the learning and development that we did at 32 nanometer high-K metal gate. And the implementation of this technology has been very smooth based on the learning that we had. So it's a very exciting node for us.
Well, that's great. And so tell us, where has the partnership with ARM enabled applications and end products?
As we said, we've been collaborating for so long that there are many products out in the market today that are built on our process technology with ARM physical IP, starting at 65 nanometer. At 45 nanometer, there are many products today that are achieving over 1 gigahertz performance at that node that are powering mobile devices as we speak. You may have one in your pocket.
Well, okay, so can you tell us a little bit about what's in store for leading edge development?
Right now we're working on our 20 nanometer. That's our next great technology node. There's lots of challenges there, so again we start very early with ARM. We already have some test structures from ARM on test chips that we're running today at 20 nanometer. So that's the next big exciting development going on.
That's exciting stuff. And I'm sure your design community is looking forward to utilizing the latest ARM and Samsung technologies here. So on behalf of ARM and Samsung, I'm Sean O'Kane, and we'll see you next time for another edition of Chip Estimate TV. Thank you so much for joining us today, Anna.
Thank you, Sean. It's been my pleasure.
Hi, my name is Sean O'Kane, Executive Director with ChipEstimate.com and ChipEstimate TV. My guest today is Chris Day, Vice President of Marketing and Business Development at Ambarella. Thank you very much for joining us today.
Happy to be here, thank you.
So ARM is leading the wave of mobile device innovation along with innovative IP optimized for consumer devices. Chris, can you start by telling us about Ambarella and the markets and technologies that you're in?
Sure. Ambarella is a leader in H.264 video compression SoCs. We supply our SoC solutions into the broadcast television infrastructure market, into consumer HD cameras, and into IP security and surveillance cameras. We are about 400 people. We focus very much on very low power with very high quality video, and we have delivered a number of SoCs already in 45 nanometer technology and lower.
That's great. So when selecting your IP and process technology, what were your main considerations?
So the main consideration for choosing IP is the maturity of that IP. In particular, we want to see that it's been used before successfully in designs, typically with other customers. We are looking obviously for low cost, we are looking for low power, and we are looking to also provide good performance. So if you look at the broadcast infrastructure business, that demands very high performance. If you look at a consumer HD camera, that is a low power type of product. So balancing them both is quite a challenge.
Fantastic. Now that you've selected the ARM Artisan Physical IP, what benefit has this brought to your HD video ICs?
Well, the first benefit is that we have successfully delivered 5 45 nanometer or smaller geometry SoCs first time right. In terms of the end products and the benefits for the customers, they are able to receive cameras that are lower power, which gives them better battery life, have the best video quality and still image quality, and are delivered at a cost point that enables them to be successful in consumer markets. So if you see cameras at Best Buy from companies such as Sony, Kodak, GoPro, Samsung, it's very probable that they are using Ambarella silicon.
That's great. So what does the future hold for your next generation development?
Well, we are always striving towards greater video quality, lower power, lower cost and more features. And I think in terms of the consumer camera market, the arrival of Android as an operating system that is going to run on consumer camera products is going to give us the flexibility and capability to deliver a whole set of new features. And of course that Android operating system is running on the dual Cortex A9s that we have received from ARM.
Well, that's great, Chris. You know, and I'm sure this very large design community is looking forward for higher performance, low power, feature-rich platforms from ARM and Ambarella. So on behalf of ARM and Ambarella, I'm Sean O'Kane, and we'll see you next time on another edition of Chip Estimate TV. Thank you so much, Chris.
Thank you.
In summary, Artisan offers advanced physical IP unmatched in performance, low power, and density ranging from 250 nanometers down to 28 nanometers. ARM processor optimization packages enable designers to achieve up to 25% increase in performance, and the majority of Artisan IP is available for quick and easy access through our Design Start web portal, available at designstart.arm.com. ARM Artisan Physical IP, where advanced SoCs start.